Welcome to Tungal online classes. In previous video, we have already discussed what do you mean by rest, what do you mean by motion, then what do you mean by one dimension, two dimension and three dimension motion. Okay, so in this video, we are going to discuss what do you mean by distance, what do you mean by the displacement and what are the difference between distance and displacement. Okay, see, the first one is distance. First one is distance. So what do you mean by this distance? So distance means a path followed by the body or the actual path traveled by an object or particle. So that is known as the distance. So then what do you mean by this path length? So for example, consider, so this is the initial point. This is the initial point and this is the final point. So that means this is the initial position of the object and that is the final position of the object. If an object is moving from A point to B point, A point to B point, so this is known as the path length. For example, if it covers 5 meter means the path length is, that is 5 meter. So here the distance means the actual path traveled by the body. So the actual path traveled by the body or the particle is called distance. Right? Okay, see the first one, SI unit of distance is, SI unit of distance is, SI unit of distance is, that is meter. SI unit of distance is meter. And second one, CGS unit of distance is centimeter. CGS unit of distance is centimeter. And the third one, dimension formula of distance is, dimension formula of distance is, that is capital letter L or m to the power is 0, L, t to the power is 0. Next one. So it is a scalar quantity. So distance is a scalar quantity. Scalar quantity. And the last one is it is always positive. So that means distance is always positive. Okay, see. So distance means the actual path traveled by the body. So that is known as a distance. The SI unit of distance is meter. CGS unit of distance is centimeter. Dimension formula of distance is, that is capital L or m to the power is 0, L, t to the power is 0. So here m to the power is 0 is nothing but its value is 1. T to the power of 0 is value is, that is also 1. Then the dimension formula for distance is, that is capital L. Okay. So here the distance is a scalar quantity. So distance is a scalar quantity. So then what do you mean by this scalar quantity? So scalar quantity means a physical quantity which having only magnitude. A physical quantity which having only magnitude. So that is known as the scalar quantity. So for example, the mass of this chalk piece is, that is 1 kg. So here 1 kg indicates that the magnitude of this physical quantity. So another example, the mass of this duster is 10 kg. Here 10 number indicates that is the magnitude. So that means a physical quantity which having only magnitude. So that is known as the scalar quantity. So here distance is a scalar quantity. And the next one, it is always positive. The distance is always positive. Okay. The next topic is displacement. The next topic is displacement. So what do you mean by this displacement? So displacement means the shortest distance between the initial and the final position of the object. So that is known as the displacement. Okay. So displacement means the shortest distance between initial and final position of the object. So for example, consider here, so this is the initial position, that is A, and this is the final position, that is B, right? So here we are consider a particle, it is moving from A point to B point in three different ways. In three different ways, right? So here the first particle that is following this path, and second particle following this path, and the third particle following this path. So you can see here. So here this is the initial position and this is the final position. So here the shortest distance between the initial position and the final position, so that is known as the displacement. So here this is the shortest distance between point A and point B, so this is the displacement. So this is the displacement. So here displacement means that the shortest distance between the initial and the final position of the object or the final position of the body. Okay, see the next point. The SI unit of displacement is, SI unit of displacement is, the SI unit of displacement is, that is meter. SI unit of displacement is meter. CGS unit of displacement is, that is centimeter. And the third one, dimension formula of the displacement, dimension formula of displacement is, that is L, or n to the power is 0, L, t to the power is 0. The next one, displacement is a vector quantity. It is a vector quantity. It is a vector quantity. The next one, displacement may be positive, may be negative, or 0. So it is may be negative, positive, or 0. So this is about the displacement. Okay, displacement means shortest distance between initial and final position of the body. The SI unit of displacement is meter. CGS unit of displacement is centimeter. Dimension formula of displacement is, that is L, or n to the power is 0, L, t to the power is 0. And the next point is, it is a vector quantity. So it is a vector quantity. So then what do you mean by this vector quantity? So vector quantity means a physical quantity, it's having both magnitude and direction. So that is known as the vector quantity. See, the vector quantity means a physical quantity, it's having both magnitude and direction. So that is known as the vector quantity. For example, the mass of this chalk is 1 kg. We are throwing this chalk towards the north. In this case, it's having magnitude and it's having a particular direction. Such quantities are known as a vector quantity. After that, displacement. The displacement may be negative or positive or 0. Right? So in previous one, the distance is always positive, but the displacement is, it may be negative, it may be positive, or it may be 0. Okay, see here. So consider in one dimensional motion, the object is moving along the x-axis. So here, if an object is moving along the x-axis, there are two possibilities of the direction. One is it may be moving along the positive x direction, or the another one is it may be moving along the negative x direction. Okay, so in this case we have considered this is the origin. So this is the origin, and this point is somewhat 50 meter. This is 100 meter, and this is 150 meter, and so on. This is 200 meter. 200 meter. So this is the positive x-axis and this is the negative x-axis. This is minus 50 meter and this is minus 100 meter and this is minus 150 meter. Okay. So here we are consider the initially a object or a body is at origin. So then this body is moved from origin to point P. The origin to point P. Right? So here we are going to find out what is the distance of that particle and what is the displacement of that particle. The first one here, the distance of that particle is the distance is that is here this is 50, this is 100 and this is 150 means the distance is that is 150 meter. The distance is 150 meter and we are going to calculate what is the displacement. So here the displacement is also 150 meter. The displacement is also 150 meter because the body or the particle is moving in a particular direction or in a single direction. So in that case the distance is also 150 meter and the displacement is also 150 meter. So next one, in next case, the same object, initially the object is at position O. After that the particle is moving at the point P. After some time the particle reaches at point Q. So then what is the distance and what is the displacement of the particle at the point Q? Right? So distance and displacement of the particle at the position of Q. So in this case the distance becomes is that is 50, 100, 150, 200. In that case the distance is also 200 meter and displacement is also 200 meter. Okay. In third case, so initially the object is at point P, afterwards it moves to the point P, afterwards it reaches to the point Q. So in this case, the initially that body is at O, afterwards it reaches the point P. In that case the distance is 150 meter, displacement is 150 meter. So after that the point, it starts from point O and reaches the point Q. In that case the distance is 200 meter, the displacement is also 200 meter. So in this case, the initially that body at present Q position, is at Q position. After some time, the body reaches to the point Q. In this case, what is the distance and displacement? Here, what is the condition here? Initially, that object or particle is at position Q. So after some time, that particle comes to the position P. So then distance at this position is, that is 200 and this is 150. The distance is 50 meter. And similarly, we are going to find out what is the displacement. So here, then how can we calculate the displacement here? The displacement means that is final position minus initial position. Here, this is the final position. And this one is the initial position. Point P is the final position and point Q is the initial position. So the displacement is equal to final position minus initial position. The displacement means final position minus initial position. Displacement is equal to final position minus initial position. Okay, see. So displacement means that is final position minus initial position. Here, what is the final position? That is 150. the final position is 150 minus initial position is that is 200. So that is equal to minus 50 meter. The displacement is here, that is minus 50 meter. So in first case, distance displacement are same and both are positive. And second case also, distance and displacement are same. In this case, both are positive. But in this case, the distance is positive and the displacement is negative. And the last case, so this is the first case, second case, and this is the third case, and the last one is in fourth case. In fourth case, we are assuming that the particle is at O position and it reaches to the point Q. So afterwards, again that particle come to the initial position. So here the fourth example is the initially the particle at O position. So after some time that particle reaches to the point Q. So after some time again it reaches to the point O. So then what is the distance and displacement here? So in this case the distance is, in this case that the distance is, that particle is at O means from here to here is 200 plus, after that it comes back to the original position means again it comes from point Q to point O, again the distance is 200, again the distance is 200, so then the total distance is, that is 400 meter. So next, displacement. Displacement, that is equal to final position minus initial position. In this case, the final position is also 0 and the initial position is also 0. In this case, the displacement is 0. In this case, so distance is always positive, but the displacement may be positive, may be negative or 0. In the first two cases, the distance and displacement both are same and both are positive. In third case, the distance is a positive and the displacement is, that is negative. The displacement is negative. So after that, in fourth case, the distance, that is 400 meter, it is a positive and the displacement is 0. So from this one we are concluded that the displacement may be 0, may be positive or may be negative. Okay. So we will see the examples here. The first one, in first example, we are going to find out what is the distance and displacement of the particle. So, okay, see here. The initially that body or the object is at A position. So after some time it reaches to the point B. So this is A point and this is the B point. The distance traveled by the particle, so that is 3 meter. The distance traveled by the particle is 3 meter. So after some time that particle that reaches to the point C, that particle that reaches to the point C, and the distance traveled by the particle from point B to point C is, that is 4 meter. So here we are going to calculate what is the distance. What is the distance and displacement, and second one is the displacement. Displacement. Okay, already we know that the distance means the actual path traveled by the body. So the actual path means that initially the body is at A position, after some time reaches to the point B, again it reaches to the point C. So then the distance of the particle is, that is path length, that is AB plus BC. So if AB value is 3 meter and BC value is 4 meter, the distance is, that is 7 meter. The distance is 7 meter. So next we want to calculate displacement. So displacement means that is the shortest distance between the initial and the final position. Okay, see here. So in this case, this is our initial position and this is our final position. Then the shortest distance is like this. This is the shortest distance between A point to C point. So then we are going to calculate what is the displacement or what is the AC value. So then displacement that is equal to question mark, right? So with the help of the Pythagoras theorem, so here displacement is equal to or AC is equal to displacement or AC is equal to. So already we know that the Pythagoras theorem, that is AC square is equal to BC square plus AB square plus AB square. So here we want to calculate the AC value. Keep AC square as it is, and BC value is 3 square. That is 3 square plus AB square. So BC value is 4, that is 4 square, and AB value is 3, that is 3 square. So this is equal to 16 plus 9. So AC square is equal to 16 plus 9 is, that is 25. Then AC is equal to under root of 25. This is equal to 5 meter. Okay, see the distance of the particle is, that is 7 meter, and the displacement is 5 meter. So distance that is 7 meter, displacement that is 5 meter. Okay, see, so in this case the distance is greater than displacement. The distance value is 7 meter and the displacement value is, that is 5 meter. So this is one example. So we will see next example, that is second example, right? So here also we are going to calculate what is the distance and what is the displacement of the particle. Okay, see, the initial position of the object or the particle is A, and this is the final position, that is B. So then the distance or the path traveled by that object, so that is given, that is 150 meter. 150 meter. Okay, in this case distance, so for our simplicity we will write the distance is S is equal to question mark, and displacement that is S bar. So here S bar indicates that it is a vector quantity. So distance is equal to question mark and the displacement is equal to question mark. So in this case this is the initial position and this is the final position. Then the distance is, that is 150 meter, and the displacement, that is x vector, is equal to, that is also 150 meter, because this is the final position, initial position, right? So that is 150 meter. Okay, one more example here. So if a particle is performing circular path, or the particle is moving along the circular path, right? So here this is the center of the circle. So it is denoted by O, and the distance from here to here, or the radius of this circular orbit, it is denoted by R. In this case, for our simplicity, we are considering the R value is, that is 1 meter. So here is also we are going to calculate what is the distance, what is the displacement. So in this case the distance is denoted by S is equal to question mark, and the displacement is denoted by S bar. S bar indicates that this is a vector quantity, this is a displacement is equal to question mark. So here first we have to calculate what is the distance. Then how to calculate the distance here? So already we know that the circumference of a circle, that is the formula. The circumference of circle formula is, that is 2 pi r. So here the distance means the actual path followed by the object or particle. So then distance is equal to, so that the circumference of a circle, that is 2 pi r. In this case they are given r value is 1. So then 2 into pi into 1. So already we know that the pi value is 22 by 7. 2 into 22 by 7 into 1, or this is equal to 3.142. 2 into 3.142. So it's equal to, so its value is 2 into 2 is 4. This is 8 into, this is 2. 0.6. So 6.284 meter. So this is the distance of that particle. So then what is the displacement? So here displacement vector is equal to, so this is equal to final position minus initial position. Final position minus initial position. So here what is the final position? Here this is the initial position and that is the final position. In this case the initial and the final position of the particle is same, then displacement is 0. In this case the displacement is 0. Okay. The next example, fourth example. If the particle is following half circular path or semicircular path. For example, this is the A point and this is the B point. The particle is following this path. The particle is following this path and this is the center of the semicircular path and this is the radius. Here r is equal to somewhat 1 meter. Here is also we are going to find out what is the distance and displacement. So distance s is equal to question mark and displacement s vector that is equal to question mark. Right? Okay, see. So already we know that in previous example we have calculated the distance. So distance means path followed by the body. So in that case we have considered circumference of circle is equal to displacement. So its value is 2 pi r. But in this case this is a half circle. So here half circle means already we know that the circumference of circle is that is 2 pi r. We are dividing this 2 equal part. This is 2. This 2 get cancelled. Here the distance traveled by the particle is that is pi into r. So here pi value is 3.142 into r value is 1. So then its value is 3.142 meter. Right? 3.142 meter. The next one, displacement. So displacement that is equal to shortest distance between initial and the final position of that body. So here this is the initial position of the body and this is the final position of the body. Then shortest distance between these 2 points is, already we know that. So this value is r. If this value is r means this value is also r. Then the total length from A point to B point is that is 2r. Then displacement value is that is 2r. It is 2 into the r value is 1. So this is 2 meter. So this is 2 meter. Okay, see in this example. So in second example the displacement and distance are equal. In second and third example the distance value is 6.284 and the final displacement is 0. But in this example the distance value is 3.142 and the displacement value is that is 2 meter. From all these observations we have concluded that distance is greater than or equal to displacement. So this is a very important point. So distance is greater than or equal to displacement. So from these all examples we have concluded that distance is greater than or equal to displacement. Okay, the last problem. So here in this problem, so consider this is a horizontal surface. An object is thrown from this point to in vertical upward direction. So here just we have thrown this object in vertical upward direction and it reaches a certain height, that is h. So after some time that object comes to its initial position. So then find out distance and displacement. So find out what is the value of distance and what is the value of displacement. Okay, see here. So here the distance means actual path followed by the body. So in this case they are given height value is given, that is h. The initially the body is moving from this point to and it reaches the maximum position. In that case, it travels, the distance is h. So after some time, again it comes back to its initial or the original position. Again it covers the same distance. So then the distance in this case is, that is h plus h, that is equal to 2h. So here why we are considering this h and h? They already given the height from O point to A point, that value is h. Then initially that body reaches the point A, in that case it covers the distance is h. After some time it comes to the original position. In that case also it travels the same distance. So then the total distance is, that is 2h. But in this case the displacement, so displacement means final position minus initial position. Here the initial position is also same and the final position is also same. So then in this case also displacement is 0. In this case also the displacement is 0. Okay. So then what are the difference between distance and displacement? You see, distance and displacement. Distance and displacement. The first difference is definition, right? So here the definition is the path followed by the object. Path followed by an object is called distance. And here the definition is shortest distance between. Shortest distance between initial and final position. Initial and final position. Okay, the next one. So distance is a scalar quantity. It is a scalar quantity, and displacement is vector quantity. It is a vector quantity. It is a vector quantity. And the third point, it is always positive. It is always positive. Is always positive. But displacement, it may be positive or negative or zero. Positive, negative or zero. And the next one, distance always greater than or equal to displacement. And here displacement is less than or equal to distance. So these are the difference between distance and displacement. It is very important for 3 marks, right? So what are the difference here? The first difference is definition. Path followed by an object is called distance, and the shortest distance between initial and the final position of the body is called displacement. And the second difference is it is a scalar quantity and it is a vector quantity. So scalar quantity means it is having only magnitude. Vector quantity means it is having both magnitude and direction. Next, it is always positive. Distance is always positive, and displacement, it may be positive, it may be negative or zero. And the last one, the distance is always greater than or equal to displacement, or the displacement is less than or equal to distance. Thank you.